Okay, this is your final review, number 2 for grade 9 geometry. And we're going to look at the segment addition postulate, which is in chapter Y. It's 5.1. So chapter, did I say 5.1? 1.5. And it says, if B is between A and C, then AB plus BC equals AC. So we're going to use this idea. Let's just go ahead and draw a quick picture of that so you can see it, and then I'll use it for the problem, the example. So when you look at the picture, if you have a segment AB and you have segment BC, the sum of those two segments, adding them together, will give you AC, the entire segment. All right, so let's go ahead and look at this first example. We've got MN to NO. And you know that MN is x, and you know that NO is 2x minus 1. So you would simply take x plus 2x minus 1, and that would equal I'm going to change that to plus 1 versus minus 1. That would equal 19. And then you have combining like terms. X, or 1x and 2x, is 3x plus 1 equals 19. I'm going to subtract 1 from both sides using the subtraction property of equality. And you're going to end up with 3x equaling 18. Divide both sides by 3, division property of equality, and x equals 6. So if I wanted to find out the length of MN, we already know that MO is 19, but if I want the length of MN, that's going to be 6, because it's right there, it's x. If I want the length of NO, it's going to be 2 times 6 plus 1, which is 13. And 6 and 13 is in fact 19, so you know you've done that correctly. So I found the value of x, that was one of my ideas, and then I found the value of the other line segments. Now, they're not all that challenging. Some of them are going to be quite simple, as you'll see in the problems. But you will have some algebra that you'll be asked to do. So I did an algebra problem as an example for the segment addition postulate. So go ahead and I'm going to write the problem. You're going to write the problems down. You're going to work them. There may not be work. Unless it's algebra, there probably won't be work. And then you're going to check your answers. Okay, here are your 4 problems for the segment addition postulate from chapter 1.5. What I'd like you to do, the first 2 are quite simple, but draw the picture, write what you are solving for, meaning write your segments. Numbers 3 and 4 have a algebraic component, so I will need to see work on 3 and 4. Please find your variable x for 3 and y for 4. And then please solve for the segments I've asked for, and please write the segment that you were solving for. Don't just write a number, please. So I will need to see work on 3 and 4, and I will need you to have all 4 parts on number 4 and 3 parts on number 3. As soon as you finish, go ahead and turn it on and check your answers. Okay, on number 1, it's segment PR, which is the entire segment, is simply 9 plus 7, which is 16. On number 2, you're given the whole segment 21. You're given part of that segment, which is LM, which is 11. To find MN, you can do one of 2 things. You can just go 21 minus 11, which would give you 10. Or you can go x, or what, plus 11 equals 21, and that would also be 10. Now we go to numbers 3 and 4, where there's a little more work. You know that AB plus BC are going to equal 23. So x plus 10 plus x minus 3 equal 23. Combine like terms. That's 2x. 10 minus 3 is 7 equals 23. Subtract 7 using the subtraction property of equality. That gives you an equivalent expression, 2x equals 16. Use the division property of equality to isolate x. By dividing by 2, and x equals 8. So our x is 8. AB is going to be 8 plus 10, which is 18. And BC is going to be 5, which came from 8 minus 3. Number 4 is you were given, this one's more challenging because you were given LM is y minus 3, and then MN is y plus 4. If you added those 2 together, y minus 3 plus y plus 4, it would equal the entire segment, which is 4y minus 15. Combining like terms, you get 2y Negative 3 and 4 is 1, equals 4y minus 15. You need to collect the variables on one side, preferably keeping the y, the coefficient with the y positive. So we're going to subtract 2y from both sides. You're left with 1 equaling 2y minus 15. Using the addition property of equality, you add 15 to both sides. So you end up with 16 equaling 2y. Use the division property of equality to isolate the variable y. You divide both sides by 2, and y equals 8. So y is 8. 8 minus 3 for LM is 5. 8 plus 4 for segment MN is 12. And if you look at this, you've got 5 plus 12, which would be 17. So you know LN is going to be 17, but you could also check it by putting the 8 inside the y position here, substituting. 4 times 8 is 32, minus 15 is also 17. Okay, the last part of your final review, number 2, will be angle addition postulate, which is actually from chapter 1.6. If you're willing to look it up. And that postulate says if P, that's a point, is in the interior, that means inside of angle RST, and you can see the picture right here, RST, then the measure of angle RST is the sum of angle RSP and angle PST, and then there's the symbolic way of writing it right there in blue. All right, so I've started with one that's a little bit more challenging, and we've got this angle MNO, and it's 2 angles. We know that the measure of angle MNO in orange is 133 degrees, and you are going to be given angle MNP equals 2x minus 3, angle PNO equals x plus 4, and you'll need to find x, you'll need to find MNP, and you'll need to find PNO's measure. So we have a little algebra involved here. So you take 2x minus 3 and you put it together with x plus 4, that's addition, equals 133. Combine like terms, you have 2x plus x, which is 3x. Negative 3 and 4 is 1, equals 133. Using the subtraction property of equality, you subtract 1 from both sides and end up with 3x equaling 132. Then you divide both sides by 3 using the division property of equality to isolate the variable, and x is 44. So your x value is 44. But I'm asking you for what angle MNP and angle PNO are. So you simply substitute the 44 in for x. 2 times 44 is 88, minus 3 is 85. For the second angle PNO, substitute in 44. 44 plus 4 is 48. If you were to add 85 and 48 together, you would get 133 degrees, which is the total degree measurement of MNO. Now, the first couple you're going to try are going to be quite simple, and then you're going to have some that have algebra involved. So go ahead and write the problems down. Please draw the pictures and solve them, and then turn the recording back on again to get your answers, to check your work. Okay, here are your final 3 problems for final review number 2, numbers 5, 6, and 7. 5 and 6 are quite simple. 7 involves a bit of algebra, sort of like the example did. Please make a note on number 6. The entire angle is 135 degrees, meaning ABD is 135 degrees, DBC is 60 degrees. So don't get yourself confused on that. Okay, when you finish solving them, I'd like for you to turn the recording back on and check your work. Make sure you draw the pictures and fill in all of the blanks. There will only be 7 problems. These are the last 3. Okay, on number 5, these are quite simple. If you put together ABD and DBC, 60 degrees and 20 degrees, you get 80 degrees. So 60 plus 20, that was your work. Could be done mentally, should be done mentally actually. Number 6, the entire angle DBA is 135 degrees. DBC is 60 degrees, so you need this missing angle. You can just subtract 60 from 135, or you could count forward from 60 to 135, which would also be 75 degrees. Also a mental math problem. Number 7, not particularly difficult, but again, not a mental math problem because there's an algebra component. ABD is x minus 6. and DBC is x plus 4. You put those two angles together to get ABC, and we know that ABC is 84 degrees, so x minus 6 plus x plus 4 will equal 84 degrees. You combine like terms, x and x is 2x, and combine negative 6 and 4 is minus 2 or negative 2, and that equals 84. Use your addition property of equality to create an equivalent equation. So you have 2x equals 86. Divide both sides by 2, which will give you, we'll isolate the variable x, and you will get x equals 43. So that's the first part. But then you needed to find ABD. 43 minus, minus 6 is going to be 37 degrees. So ABD is 37 degrees. Go to DBC, and that's x plus 4. So substitute in 43 for x. 43 plus 4 is 47 degrees. If you were to add 37 degrees to 47 degrees, you would end up with 84 degrees, which is the total of angle ABC. You will be turning this assignment into me, so please make sure your name is on it, and please make sure you have drawn all the pictures and answered all the questions. If you want, you can write the examples down. If you don't want to, you do not have to.